Um, so first of all, I have to give a short apology that I might be coughing a bit and such. The flu got to me, so just in case that you're aware. Um, I want to talk about the report Wildfire Signal 23, which is a report we at the NIPV published earlier this year in January, which is basically a first outlook towards the wildfire risk in the future. Um, so the reason why we wanted to do this is we're all saying the same, right? Climate change is not doing as well. And there's a strong basis for it, but it wasn't written down yet, or not fully written down yet. And also there's the question, besides climate change, what else is changing that is affecting wildfires? But the main reason is, of course, to have something, a report that forms a strong basis and proof for further work or further actions, for example. And I have scientific between brackets because there's scientific work involved and scientific research used in the report, but the report itself is not a scientific paper. So the report had a couple of goals. To gain insights in the future developments of wildfires, of course, but also to present recommendations in order to limit the development of the wildfire risk. So it's not just this is an issue, it's also there's an issue, but we can do things. And finally, it's to identify research topics that need to be addressed in the next few years in order to timely supply the needed knowledge so that the wildfire risk can be limited, which is a big task for, I think, all of us here. So we posed 3 main research questions, or 1 main one and 3 sub-questions, which are: how is the susceptibility to the occurrence of wildfires changing? So that's basically ignition, yes or no. How is the susceptibility to the development of the wildfires changing? And that's after ignition, what will the fire do? Will it spread quickly and be intense or not? And finally, of course, how is the impact of wildfires changing? And if we want to look at the wildfire risk, we needed the third question. So to get an idea of the wildfire risk, we needed to take a look at the impact. This work was not done by just the NIPV. We couldn't do it ourselves, so it was a collaboration of quite a few partners that had a lot of great input and recommendations. So it was the NIPV, the Vrije Universiteit Amsterdam, University in Amsterdam, the VU, Wageningen University in Research, the VUR, Katelijne Stoof, who I'm sure most of you know, participated here. The Koninklijk Nederlands Meteorologisch Instituut, the KNMI, which is the Royal Dutch Meteorological Institute. And finally, an institute called Deltares, which I believe is a commercial institution, but nevertheless is a knowledge institution, and hence was also able to deliver valuable input. So a bit about what did we do, what was our methodology. I'm not going to dive too deep into these things, but in general, what the main thing was is doing a literature study and interviews to see what type of knowledge the different people from the partner institutes have, and scientific reports and such that they have that can be used to write down how we expect the wildfire risk is changing. The KNMI has made something called Climate Scenarios, which was published in 2014, and they will give an update this year, but that's still not published yet, where they basically give an overview of 4 possible scenarios in terms of climate change for 2050, for example. So those scenarios were used, of course, to get an idea of how is our climate changing and to be able to tell what that will mean for the wildfires. And finally, we had 2 workshop days where we gathered with all the partners and all the people involved to discuss the findings, the structure of the report, and to translate all the information that was gathered towards wildfires, because most input was not necessarily about wildfires already. So we needed to do the translation ourselves based on our expertise and experience. And finally, a small addition was an analysis of relative humidity, because that's a factor that in climate data, and well, it's available in climate data, but in climate outlooks and the climate scenarios is not that much highlighted. So we did an analysis of itself, where we looked at the whole year, spring and summer, and then looked at, okay, what is the average relative humidity and the number of days where the relative humidity goes below 50%. And from that data, we calculated the climate average to be able to find a trend in terms of climate change. And that climate average is a period of 30 years. So it's a moving average. Every year we take that year plus the 29 years before and calculate the average. Then we make a line, and finally you can identify a trend, and you'll see it in a bit. So when you start reading the report, the second chapter is an introduction to wildfires. I'm not going to give it to you because I'm sure most of you know this, but I want to explain why we added this. And the reason was writing down definitions to make sure that everybody talks the same language. And next to this, discussing relevant factors for wildfires, which we come back to later on in the report as well. So we keep using those same factors, which was biomass and its availability to burn, weather conditions, or as many probably many of you will know this as well, fire weather, and finally ignitions. But mainly anybody, so any firefighter or researcher or politician, should be able to understand. I put largely here because, of course, it's still relatively technical and can be difficult at times, but hopefully this gives a greater understanding, and also understanding what's discussed later in the report. So let's talk about the contents. We built the report in the same way as the research questions were posed. So starting off with the occurrence of wildfires, I have added this figure here, which is from the data set that Wageningen University and the NIPV is keeping track of and analyzing, where we analyze the data of 2017 until 2021 in this case. Of course, the data is still being gathered, but the analysis was done in that period. It's short, it's only 4 years, but it's just to create an idea of what wildfires in the Netherlands are doing. And I think all of us will see the same thing here, is that 2018 has a very high peak in July. And 2018, for your information, was an extremely dry year, and especially also during the summer. So there was a peak in wildfires. If we look at it per year, 2018 had almost 1,000 wildfires in the Netherlands. Another information that you could find here is, for example, most of those fires, about 85%, I would say, are less than 1 hectare in size. Only the rest is larger, and especially the really large ones, or over 10 hectares, is just a very small portion. And the vegetation that is burning, for quite a lot of fires, we don't have the data. But what we do know is that agricultural fires, we have them, but not that many. Then in wooded, so forested areas, there's about 25%, but there's over 30% non-wooded, which is, for example, heather, a very burnable vegetation type that we do have in the Netherlands quite a bit of nature areas. So looking towards the future and the occurrence of wildfires, of course, the first look is towards climate change. And for your information, in the past 30 years, there's been a 1.1 degrees Celsius increase in our average temperature, and the greatest warming is visible in springtime. In total, so since climate change started, we're over 2 degrees Celsius, but in 30 years, the past 30 years, it's been 1.1 degrees Celsius. Now, when we look at what's been observed and also what we expect, it's a very interesting thing, because we expect more precipitation, but also more drought, which feels counterintuitive. But there's a difference here when you look throughout the year. So almost every season except for spring was forecasted to become wetter in absolute numbers, and especially fall and winter time, they would become wetter. And however, That's absolute. When we talk about relative things, spring and summertime will become drier, even though there might be more precipitation falling in absolute numbers. The drought will increase, and the reason why is that this precipitation will fall during, for example, thunderstorms with a short period but a high intensity rain. Quite a bit, quite a large fraction of that rain will not enter the soil. And if you add a warmer air and more sunshine, which is what we have been observing in the Netherlands as well, that means more evaporation, and at the end, a stronger or larger drought. The first figure of the analysis of the relative humidity is shown here. Yes, I know it's a beautiful Excel figure, but it gives a quite a nice idea of what's happening. So the data is from 1950 up until 2021 here, and in order to calculate the climate average, this graph starts at 1979, so that we have a period of 30 years. Back in about 1980, we had about 60 days throughout the year where the relative humidity went below 50%, which is an assumption that below 50% conditions turn towards burnable. If we look towards 2020 in that area, we are already at about 75. So that's an increase of 15 days over a period of approximately 40 years. So we can clearly see here that the climate is changing and our air is turning drier. The reason why is known. It's because land is warming up more quickly than the sea and the oceans. So there will be more moisture in the air, but because the air temperature is increasing more quickly and can contain more moisture, the relative humidity goes down. And also this increase is visible in both springtime and summertime. And springtime is our general fire season. Summertime is being added more and more, and which is also visible here because spring has more days with relative humidity below 50% than summer. Looking towards the future, we do expect a more flammable nature. Most of the scenarios show a similar image with warmer, drier, and a sunnier climate. The extent and the strength of this is still uncertain, but this is a clear trend. And also the trend in the past, so the things that we have observed, is the same as what we expect here. So it is quite likely that this trend will continue at least for the next few decades until hopefully things change with CO2 reduction and such. Now, this is also something we can see in the groundwater level. So this is just a picture for your to create an idea, where it shows the change in the mean lowest groundwater level. Red is of course getting lower and blue is getting higher. And interestingly, the majority of the Netherlands turns orange or red, so showing a decrease in this groundwater level. But you can see some blue, and especially here, the biggest nature area of the Netherlands, the Veluwe, shows blue, which again feels a bit counterintuitive because, okay, it's getting drier, but the groundwater level is going up. But I have to say here that these are here, and also at the coast and the dunes, these are all sandy soils, where the groundwater level is tens of meters below the surface. So because more precipitation is falling, that groundwater level is changing, and the evaporation is not that strong there because the water is so deep into the soil. Nevertheless, adding, for example, 1 or 2 meters here at a groundwater level that's, for example, 30, 40 meters below ground, that doesn't have any effect on the vegetation. So the vegetation still dries out stronger because of the conditions in the atmosphere, and the groundwater level, even though it's rising, has little effect or no effect even. Then another thing is what we're seeing is an increase in biomass, or what we expect, because our government has stated we want 10% more forest, which in a very short step also means more potential fuel. For the rest, vegetation change is still an unknown factor. There's more knowledge available on it. Unfortunately, it was not possible to look at it at this time, but we do want to look at it further in the near future, hopefully. And finally, looking at ignitions, right? what we expect and what we see is that we get more people in the Netherlands, a rising population, and more recreational use as well in nature, in or around nature areas. So translating that to ignitions, knowing that most of our ignitions come from people, whether it's people consciously igniting wildfires or whether it's accidental, for example, it's very likely that because of this change, we also expect more ignition sources. Well, will it turn towards more wildfires? That's we have a figure for that here, where you can see the current situation and the 2050 scenario. This is the least positive scenario, of course, but it gives an idea of what's happening. And it combines both information about climate change, but also information about recreational use as a predicting factor. And then what we can see is that a large part of the Netherlands will turn towards a higher susceptibility to the occurrence of wildfires, where this is the Veluwe again. It was red already in quite some parts, but now it's almost fully red. The dunes turn red, but also, for example, here, a lot of green areas turn yellow. So all this combined means we do expect more wildfires. Then let's talk about the development of wildfires. And again, I have the relative humidity here, but in this case, the climate average for the daily lowest relative humidity. So this is the daily minimum during, what is it, somewhere in the afternoon probably. And once again here, you can see that our average relative humidity or daily lowest relative humidity is decreasing. And interestingly, here below is something visible where there's this crossover point, and springtime is decreasing more rapidly than summertime. And of course, a lower relative humidity could allow a more intense fire. Looking at climate change, it's the same story. It's warmer, drier, and sunnier. So translating that towards wildfires, that would mean an increasing intensity and complexity. And another concern that we have is a decreasing relative humidity allows a easier occurrence of thunderstorm outflow. So showers of thunderstorms creating downdrafts and creating changes in winds and increase in wind speeds that can, for example, affect wildfires and make things complex because the wind direction suddenly changes. Then looking at vegetation, as I mentioned, it's uncertain. However, there are a few factors that we wanted to discuss. So more nature and more nature areas being attached to each other could allow bigger wildfires because the fire will not stop anymore due to a lack of fuel. So you create a fuel continuity. Vegetation stress is probably also changing due to climate change, but also insects. And there's a important thing here going on in the Netherlands, which is nitrogen deposition, that is affecting nature and, for example, affecting the vitality of certain tree species. Again, trees that are becoming more stressed because of too much nitrogen in this case can become more burnable. And that has an effect on your fire behavior, for example. And finally, dead fuel accumulation, which is done in quite some parts in the Netherlands. And for example, because of biodiversity, which has an important role there. And it's pretty good for short-term drought, right? Because it keeps the moisture inside the fuel for some time. But when we have a long-term drought, then things change and it's all available fuel. That means a higher intensity fire as well. So when we look at fire behavior and combining these things, we expect more uncontrollable fires or fires that will require prolonged deployment in order to stop it. So there's this schematic figure just to create an image where you can see 3 lines. So the blue line is your extinguishing capacity. It will take some time for your first fire trucks and such to arrive. Then with scaling up the incident, you get more capacity until a certain limit. And then there's the fire intensity, which in orange or yellow is in the current climate. And just in the schematic way, we expect the fire intensity in a future climate to climb more quickly and get higher as well in the end. And that means that this crossover point from a fire that's possible to stop and probably very small towards a prolonged deployment, it can be reached earlier, meaning that it's more critical to stop the fire early if you don't want a prolonged deployment, right? So then the final thing is the impact of wildfires. And just for it to give you an idea, wildfires already have a large impact in the Netherlands. And since we are a small country, but have over 17 million people living here, we can have small fires that have a large impact. And an example of it was last year, where we had a fire of about 3 hectares in the west of the Netherlands, and a campaign got preemptively evacuated. And other examples are 2 fires in 2020, one of which is the largest one we've had for as far as we know, in the Durance Appeal. The Mijnweg one, a town of 4,000 people got evacuated, and with the Durance Appeal, for example, a care home and certain people living in houses close to the nature area had to be evacuated. So generally speaking, in the Netherlands, where there's fire, there's people. And that, of course, creates an issue. Also in 2010, there's about over 500 people that had to be evacuated. So when speaking about impact, it's of course difficult to, for example, quantify it, but we just wanted to give an idea of what is possible. So one could think of a failure of vital and vulnerable infrastructure, and think about electricity, for example. Damages to flora and fauna, so plants and animals and such, but also logically the impact on the human health. And that's not only due to, for example, the fire or the smoke, but could also be a mental thing. And another thing that we talked about is the exhaustion of firefighters. Partially, if a fire gets more intense, that will, well, you will need more energy to fight it, right? But also when in a warmer climate and warmer air, that makes working in outside for probably hours even more difficult. So you get exhausted, and that results in a reduced alertness, which can be dangerous, of course, because you're working in a wildfire and you're working probably close to or inside fuel. And finally, when we're talking about humans, we expect more people and more recreation. We expect more fires that can burn more intensely. So combining all of that, you get an idea that the wildfire risk will become higher. So in conclusion, what we've written down eventually is that we do expect more wildfires to occur, and these wildfires can burn more intensely and become uncontrollable more quickly. And finally, we have a further densification of the Netherlands, as we called it. So more people that have to live in or near nature areas, for example. And these changes in fires, a larger impact is likely. So answering the main research questions that we have, what will the wildfire risk do in the Netherlands? We expect it to increase. And we gave an extra note here that we do not expect it to become linear, especially after you have had a few very wet years, for example, you can have an extremely dry year. So during those wet years, you will not see a lot in terms of wildfires, and then suddenly your wildfires change quickly in the year after when it's extremely dry and warm, for example. And finally, we expect this wildfire risk to change quicker than climate change itself, because factors such as heat, droughts, etc., will affect each other in terms of wildfires, and they accumulate. So in the end, we posed a few recommendations. The first one is wildfires must become a structural part of the system surrounding fire safety. Of course, quite some things are already being done in the Netherlands, but we also still have things to do. One of which is a larger role in the fire service system that is currently still relatively urban orientated. And we currently do not have a national action strategy to mitigate the consequences of wildfires. And an example one could think of is thinking about multi-layer safety. So, which is 3 layers. The first layer is thinking about measures that reduce the occurrence of the incident, in this case wildfires. The second layer is reducing the impact, so making sure that campings are kept safe, etc. And finally, the third layer is measures that improve the incident response and crisis management. And this is something that's, for example, being done very strongly in terms of water in the Netherlands. I'm sure you all know that we are doing quite well in terms of water and defending ourselves against high water levels in the sea, but also in rivers. And this is the same application, that this multi-layer safety that's being done for water. So what one could think of is taking a comparable system and putting it into practice for wildfires. The second recommendation that we have is that topography and weather cannot be changed, or at least not changed much, but landscape design and vegetation can. So measures such as rewetting nature areas, applying prescribed burning or doing it more, they can help in reducing the wildfire danger and eventually wildfire risk. But it also means that a cost-benefit analysis is needed for every nature area. And it's important to think about customization here, because one measure might work in one area, for example, a peat area, but will not work in the high and dry sandy soils that we have. And finally, residents and users in or around nature need to take action as well. So there's also responsibility of people themselves. And the final thing is we need to get more knowledge about wildfires. So that's, for example, about data surrounding wildfires, enhancing the data, but also the development of climate change and getting a better idea. Earlier I mentioned the new climate scenarios will be presented somewhere this year. And of course, that means that we have to re-examine what that means for the wildfire risk as well. And also nitrogen deposition, right? What does that mean for vegetation and eventually the wildfire danger? For forecasting fire weather is getting a better understanding of typical patterns that we have, so synoptic weather, when large fires can occur. Another thing is getting a better understanding of cascading effects of wildfires, measures that are or can be taken in nature, and thinking, okay, this could be good, this could be bad. And when measures are taken, monitoring how they perform. But also another example is alternative tactics and techniques that can be used in fighting fires. Of course, this is just a part of the things that can be done and we need to look into, but hopefully it gives an idea. Finally, there are a few uncertainties still that need to be discussed. Of course, climate change is still somewhat uncertain. We work with scenarios and some of them are more positive than the others. I put vegetation with 3 question marks here because that's still the main unanswered question. How will vegetation change in the Netherlands? Then another thing is that this report has been written and the data has been analyzed in a very qualitative point of view. So we have not written down anything in terms of that the wildfire danger will increase with a factor 2.5 in the next few decades. So that's an analysis that, of course, requires assumptions, but something we could still and should still look at. And finally, most of the factors that are described in terms of climate change are about averages. So also, for example, drought and the changes in it is an average. But the question is still, okay, what about the extremes and how often they occur? So of course, wildfires will definitely occur during those extremes. So that's definitely something to keep in mind. If you want to read the whole report, we have it published on our website. I put a link here. You can take a screenshot, but you can also reach out to me or one of my colleagues and send it to you. Of course, you can find it on the NIPV website as well. So with that, I come to the end of giving you an idea of what we have done and described in the Wildfire Signal 23. And if you have any questions or want to discuss something, yeah, let me know. Thank you.